You're listening to the Things podcast, brought to you by the Things Industries.
Niklas, welcome here from Epishine.
Thank you.
Thank you very much for being here at the podcast table. How's it going so far?
Yeah, I think the fair has been really good so far. It's been more hectic than I expected. We are exhibiting for the first time together with the EPs this time.
Okay.
So we had a lot of traffic to the booth this morning and during the day. So I'm happy so far.
Okay, good. So you did not have time to stretch your leg outside.
Not that much.
Oh, that's good. That's good news, I would say.
Yeah, it is.
That's good. And what are you guys offering? What is your proposition?
Epishine is producing organic printed photovoltaics solar cell. And we are printing this on PET plastic. So it's a very thin end product. It's only 24 millimeters in the end product. We are doing this, everything we do is with mass production in line. So we don't do anything that just comes from the lab and we cannot deliver on. So everything we do is fully focused on being run in production line.
Okay, and the version is in mine in Germany.
It is in Linköping, Sweden.
Oh, Sweden. Okay.
Nothing. The headquarters and everything is in Linköping, Sweden. Okay. And then we have a sales rep in the US and China.
Okay.
So we are trying to expand as well.
And where are you based? Where are your headquarters based?
In Linköping.
Oh, okay.
Everything, production and everything is there.
Okay. So you have you're printing PV, basically, and you print it on PET plastics. That sounds to me like a plastic bottle.
It's kind of that. Yeah, exactly.
Okay. So you print this on housings, I would say then.
No, it is a standalone product, so that you need to integrate with something.
Okay.
So you need to connect it to some kind of power management. You need some kind of storage. That's the holy trinity of the energy harvesting thing.
Okay.
And then you need to apply this instead of the battery.
Okay.
Or as a complement to your battery in your product.
Okay.
Either to make it fully autonomous, which is our goal, of course, but you can use it as a lifetime extension of the battery as well.
Okay. So instead of a battery or in addition to a battery, you can use your device. You can print it on a housing.
Yeah.
You can include in the housing.
Yes.
And is it for indoor or outdoor use?
It's for indoor.
Okay.
So we are focused only on indoor for this first generation of our product.
Okay.
So it's optimized for the visible spectrum. We are stating in the datasheet that we work from 22,000 lux. I mean, we detect and can harvest NB from 1 lux, which is kind of total darkness.
Okay.
What you can do with that, then it is hard to say because it's tiny.
Okay.
Still, we can see it.
Okay. In the light we are now sitting in, is that enough for power to pass?
Yeah. This is really good lighting, I would say, especially with this light here.
But
So with this, you could probably power temperature humidity sensor sending every 2 seconds or every 3 seconds.
and I'm just interested, what kind of applications, Niklas, do you foresee for this kind of technology? Where is the market for you?
When we started, we thought that the market would be within smart buildings, smart homes, with this temperature humidity sensors.
Yeah.
There is a market there. The players are rather small, so it's a very fragmented market. So it was a lot of effort getting small volumes. 2 years ago, we started looking into remote controls, which at the moment were the hot thing. Still hasn't really taken off, but I think it's coming this or next year. And then asset trackers is where I think we can do most beneficial for the customer.
Okay, again, the question, where is what? That's always the question.
Yeah,
where is what?
Exactly.
Even for remote
Same
where is what?
For in-guy production, where you pass things around, where is your tools, where is your hospital bed?
Yeah.
Kind of. I heard that is a thing that get lost a lot.
Yeah. The where question is often a driver for IoT. Yeah? And the next stage is what? What is the status? What's happening with it? With where is, of course, we come from the machine to machine. Track and tracing is, of course, something we're familiar with. Okay, so where is something? And then, of course, so you can also power sensors, I presume. And then what is the status and read it from the
Exactly, yeah.
Okay. And typical, if you look at a typical integration project, what does it involve? So what do people need to take into account if they want to do something like this? And say, well, I like that. Let's forget batteries. Let's put a super cap in and a storage. What do they think about?
You should say you need to think low power from the beginning.
Okay.
That's a great thing to do. I mean, we have tried to do retrofit on the existing sensors.
Yeah.
Which people say, yeah, they are low power. Hey, I only consume like 100 milliamps. It's nothing. I say, yeah, but we produce 100 microamps. So we have a bit of a difference there.
Yeah.
So keep that in mind. It's of course important.
Yeah, but my experience is that a normal ESP32 microprocessor in sleep mode is 7 microamps. So it's already deep low.
Yeah. That's good. If you can get down to there and have your product on average at 7 microwatts, perfect.
Then you sleep, you put them in deep sleep mode.
Yeah, that's also a thing you need to kind of, it's already in low power rating, of course, I guess, but putting things to deep sleep when you're abusing it.
Yeah.
That's
Like a remote control vessel. It's like, yeah. So trackers, remote controls, and these kind of things. And
all is worse.
okay. And what are the biggest challenges for these kind of courses for you? What is the challenge?
So I would say convincing the market that this technology actually is mature.
Okay, we help you here. So
Yeah, absolutely. Yes, we help. This is perfect. Yeah, I mean, when I started Epishine 4 years ago, we had to call the customer and say, "Hey, you want to try any artisan?" That's nah, we don't. It doesn't work.
Batteries.
They are coming.
Yeah, batteries are so old. It means that
Everyone knows what that is.
we left that area already. So we don't talk about that. The B word is forbidden.
Yeah,
You got the B word. So it's super caps and PV.
Yeah.
Indoor PV.
And so we are always. I mean, we want to send our solar panel, but we cannot send that as it is. Now we can send it as is, of course, but you need some kind of power management. You need some kind of storage. So we're also trying to get ecosystem where we partner up with all these kind of suppliers to be able to present a full solution to the customers. Yeah, we're also seeing that you can select the best PD from the data sheet, the best PMIC from the data sheet, the best storage from the data sheet, but they will not work together.
Right. In the end, some microprocessor needs to run on 2.7 or 3.3 volts, so it needs to work in the end.
Exactly. So that's what we're trying to do: complete the full system and hand it to the customer. Say, hey, you can take this if you want. If you don't, if you want to do if you want to do it yourself, fine. But we know this works.
Okay. And so you also have some kind of engineers who are able to support the engineers.
Yes. Yeah.
And okay, this was the flyer part, the leaflet. What are the costs? So I need to invest in this. What is the typical cost for such a PV in there?
The cost will always be right.
This is
I mean,
well, this is the part in the podcast where people are triggered. So you need to go.
It depends. Really depends on volume, because since we are producing roll to roll, we have a really big cost benefit for volumes.
Okay.
So if you want 10 units, we need to produce a roll.
Okay.
If you need 10,000 units, we produce the same roll. Yeah. So I mean, you pay for the rolls.
And do you already have something off the shelf that people don't start with?
Yes, we have a few standard sizes that we can ship to the samples.
Okay.
And then you can, of course, make a customized SEM. Then I would say you need volumes of 100K or something like that.
Okay, but let's start the audience. Let's start with the proof concept.
Yep.
Order those standard off-the-shelf PVs.
Yep.
What is the cost? 100,000, €10, $1.
There we are competing with batteries, and we would like to get to the price of a battery. We're not really there yet, but that's the aim we are going for. So I hope to say anywhere from $2 to $10, depending on size and volume.
And the good news is they won't get empty.
Exactly. They will last forever.
Niklas, thank you very much. Good luck, and we see you again, either in the products of the listeners or in the competing products. Thank you very much.
Thank you.
Thanks. Good.